So here we've got a question involving congruent triangles, and at GCSE level that tends to mean we're looking to prove either the two triangles have got the right angle hypotenuse side property, which basically means we show that the two right angle triangles that we're working with have the same hypotenuse length and one of the sides being the same. Through Pythagoras it doesn't matter which one, because once you've fixed one of them then the other one will be the same anyway through Pythagoras' theorem. We either prove side, 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 so in other words both triangles, all three sides are identically lengthed. We could prove side angle side, so we're basically going to try and prove that the side length, the angle tracked between the other side, is the same in both triangles, or we try and prove angle angle side or angle side angle, where the triangle would have an angle trapping a side to the next angle. Angle angle side works as well, remember, because angles in a triangle have to add up to 180, so this angle here would create angle angle side and so forth. So we've got to show that from this picture we can create one of these conditions for both triangles to hold, so therefore we prove that they are congruent, in other words identical, all angles the same, all lengths the same. So we go through the information, adding it onto the picture. So we've got LMB is parallelogram, so that means that this side length is equal to this side length, this side length is equal to this side length. This angle here, doesn't matter what size it is, so we might as well just call it x, it's got to be equal to the opposite angle there. And this angle here, call it y, it's got to be equal to that angle there. And because angles on a straight line are up to 180, then we can say that that must be 180 minus y, and we can say that that must be 180 degrees minus y as well. What other facts do we know? Well, they're telling us things about midpoints. So basically they're saying to us that L is the midpoint of AB. So if I put that there, then this must be the same length as that one. M is the midpoint of AC. So that length there has to be the same as that length there. And N is the midpoint of BC. So if that's that length, then this also has to be the same length. So we've labelled the triangle up with all the information that we can put on at the moment. Let's see if that helps us decide what's going on between the two triangles they want. Well, they want ALM. So ALM, well, we can see already here we seem to have a side angle side, which would be nice if we can show that we've got a side angle side in the other one as well. Well, that length is the same as that length. That angle is the same as that angle, and that length is the same as that length. So it looks like we're going to show that side angle side is true. All we've got to do now is write down how that all happened. So we're going to say that angle ALM equals angle MNC 180 degrees minus y, and we're going to give reasons. Angles on a straight line add up to 180 degrees, and we're going to say that AL equals MN, equal lengths, opposite lengths in a parallelogram, and AL is the midpoint of AB, where LB equals AL. So we're justifying why we chose that length and that length to be the same. So we've got the angle, we've got a side, we need the other side. So basically we're going to say that LM equals NC, and basically it's the same idea as before, really. Equal lengths, opposite lengths in a parallelogram are equal, and given that LB not LB this time, it's BN, isn't it? Sorry, yeah, so BN equals NC equals LM midpoint given fact. So basically we've chosen all those reasons, and so we finish off with a sentence ALM must be congruent to MNC as we have shown SAS condition holds for both triangles. Okay, so it's basically a case of we use the information to label a triangle up. We call this angle X and opposite angles, so we might want to add on that opposite angles are equal. Just to show the examiner again, we're understanding what we're doing. Opposite angles are equal in a parallelogram. So on. And then we showed that that length is the same as, sorry, it's 2 dashes, midpoint, same as that one. And we showed that this length was the same as this one because opposite lengths in a parallelogram and so forth. So a bit of a run through on congruency and how you might work out missing lengths and angles in shapes like that.